Alright, this video is about solving polynomials. Now, in order to understand solving polynomials, we want to first understand this thing that's called the rational root theorem. We'll talk more in class about it, but the rational root theorem basically tells us that if there is a rational root, it has to be an exact value where the graph passes through the x-axis, known as a zero. Alright, we're going to use this idea from the rational root theorem. All right, finding that x-intercept, as long as that x-intercept is a whole number or an integer or a rational number. The second term that we're going to use here is called the fundamental theorem of algebra. Now, this fundamental theorem is pretty involved, but basically here's the way we're going to use it. Whatever the highest power is, whatever the degree of the equation is, that tells us how many answers we have to find. Okay, that could include both real, rational, and complex answers. Real, rational, irrational, and complex. So, how do we solve a polynomial? I would encourage you to copy these steps down on a separate piece of paper you can have right next to you. Step 1, we're going to graph and determine the number of solutions. Step 2, we're going to identify any or all rational zeros. Step 3, we're going to pull out, using synthetics, the rational zero or zeros. We should end up with or be left with a quadratic. We're going to then solve the quadratic, and we're going to focus on two techniques of solving the quadratic. We're either going to use square roots when there's no b, or we're going to use the quadratic formula. All right, and remember the quadratic formula, we use the discriminant technique, but it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then the last thing we're going to do is list all solutions. All right, so starting off with this first example, the directions are solve. Right away, I know that I am expected to get 3 solutions. Why? Highest power is 3. That's what the fundamental theorem of algebra tells me. Now, all 3 of these answers could be rational. One of these 3 answers could be rational, and the other complex, the other 2 complex, or the other 2 irrational. So what I'm going to do is I'm going to take this and graph it. Now, I already put this on a graph. All right, I graphed it, and I noticed that this graph, the blue graph here, goes through the x-axis in 1, 2, 3 spots. Those x values are all 3 rational. I know that all 3 of the answers that I had to find here, I just found. So this would be the easiest scenario when I get x is negative 3, 0, and 2. And I'm done. All right, so let's look at a second equation here. Let's say that I say g of x is equal to x to the 4th minus 81. All right, I know for this problem I'm supposed to get 4 answers. So the first thing I want to do is take this equation and graph it. So I'm going to come back over to my graph. I've got it entered in there. I'm going to turn that off. And I notice right here, it goes through the x-axis at negative 3 and at 3. Because it was degree 4, the fundamental theorem of algebra tells me I should get 4 answers. But I'm only seeing 2. That's all right. We're going to write down the 2. So I know right now, I know that x is equal to a negative 3 and a positive 3. Now I got to go find the other 2. There's supposed to be 4 answers. All right, so how do I do that? I take these 2 answers out using synthetic division. So my box number would be negative 3. Coefficients are 1, 0, 0, 0. Let's see, that's cubed, squared to the first, negative 81. And I better get a 0 for the remainder because I know that it is a root. So let me keep going here. That gives me 81 or 0. I have now confirmed what the graph told me. The graph told me -3 was an x-intercept or a 0. I've confirmed it now. Now I'm going to take the second one out from this line that I just created. So I'm going to do synthetics again, but now with 3. It gives me 1, 3, 0, 0, 9, 27. And again, I better get a 0 there. If I don't get a 0 for the remainder, I did something wrong. All right? I have confirmed that 3 was also a 0, but I still have 2 to find. Now, I started with x to the 4th, and I pulled 1, 2 zeros out, which means this line really represents 1x squared plus 0x plus 9 equals 0. Or, I don't really need that 0x, but that 0x is telling me, hey, you want to solve this quadratic by square roots. So my problem to solve is x squared plus 9 equals 0. I'm going to subtract 9. I'm going to take the square root. Remember, when you take square roots, it's plus or minus the square root of -9, which would be plus or minus 3i. There's my other two solutions. I come back up here, and I'm going to write x is equal to 3i and -3i. And now you can see I have 4 solutions. 2 that were rational, 2 that were complex or imaginary. So let's look at example number 3 now. For example number 3, I have the equation f of x is equal to x cubed minus 8x squared plus 16x. The fundamental theorem of algebra tells me I should have 3 solutions. To find where they are, I'm going to first go to the graph. So let me turn that one off, turn that one on. Now notice it cuts through right here at 0. That's definitely a 0. I see it touches right here at 4. And this is where some of the prior knowledge comes into play. I have zeros at 0 and 4, but I'm supposed to have 3 answers. Because this graph comes down, touches, and gets back off, I know that this has multiplicity. So I can go straight to my answer here, and here's what I know. I know that x is equal to 0. I know that x is equal to 4. I think it was 4, wasn't it? Yeah. But that 4 has multiplicity of 2. So I have 0, 4, and 4. There's my 3 answers. All right. That one was another one where the graph told me everything, but I had to know how to interpret the graph. Let's take a look at this one. F of x is equal to x cubed plus x squared minus 3x minus 6. All right, in order to solve this, first thing I'm going to do again, go to the graph. So let me turn that one on. And I notice that it goes through just once at 2. So I'm going to come back over here and say, okay, I know x is equal to 2. But the fundamental theorem of algebra tells me I'm supposed to have 3 answers. I'm going to take the one answer I know out. How do I do that? Synthetic division. So let's see, I've got 1, 1, -3, -6. All right, perform synthetics. And I get a 0, so I know I did it right. And that's the only thing to pull out. So what does this 1330 represent? X squared, because I started with 3, took 1 out, plus 3x plus 3 equals 0. This is the quadratic now that I have to solve. Because I have a b value, I'm going to solve it by formula. So I'm going to do the discriminant technique, b squared minus 4ac, which would be 9 minus 4 times 1 times 3 or 9 minus 12, which is negative 3. The discriminant tells me my other two answers are going to be complex. Step 2, take square root. This simplifies to the square root of 3i. Step 3, plug it into the quadratic formula. Opposite of b, so that would be negative 3, plus or minus the square root of 3i over 2 times a. And now look to simplify. I can't simplify that, so that's my next answers. Notice a plus or minus there, that's two answers. So x is equal to negative 3 plus or minus square root of 3i over 2. Supposed to have 3 solutions. I got 3. All right, let's try one more. For example number 5, let's say I have f of x is equal to 2x cubed minus 8x squared plus 9x minus 9. All right. First step, go to the graph. Looks like there's a 0 here at 3. So write down the 0, x equals 3. That was the only place that it passed through the x-axis. Pull it out. There's still going to be 2 more zeros. All right, so I have 3, let's see, 2, negative 8, 9, negative 9. Synthetics gives me 2, negative 2, 3, 9, 0. Because I got a 0, I know it did it right. And this polynomial quadratic is 2x squared minus 2x plus 3 equals 0. That's what I have to solve. Again, because I have a b, formula. B squared minus 4ac would give me 4 minus 4 times 2 times 3, or 4 minus 24, which is negative 20. Too complex. Square root. So remember, this would break down to the square root of 4, square root of 5, square root of negative 1, or 2 radical 5i. Go to the formula. X equals the opposite of b, so b is negative 2, so there will be 2 plus or minus 2 radical 5i over 2 times a, which in this case would be 4. Now notice how I've got a 2, and a 4. They can cancel. So I'm going to do that to show my final answer, and this would be 1 plus or minus 1 radical 5i over 2. And there's my 3 answers. I hope this helps. Let me know if you have any questions.